How's it going, everyone? Elder Gonzalez here again, and in today's video we're going to talk about now of how class works behind the scenes, this new keyword that was introduced to the ECMAScript, the JavaScript language, in EX6. And now we're going to make a quick recap of this particular course, where the entire reason to recap this course is to now understand and be able to express in a clear and concise way what it's all about. Specifically, what it means, this object-oriented programming, and how this allows us to write programs that can scale, so we can do that in a professional engineering environment. So the reason of why this is important is to not only understand is the language domain specific knowledge, okay, but now, which is something that a couple companies are looking for, is to see how you can now improve your soft skills or be aware of your soft skills, whether it is you have patience, you are empathic with another person, as well as if you're following the good engineering practice. Lastly, but not least, is how is your technical communication, something that I'm doing here, as well as your analytical thinking. So the analytical thinking and your technical communications are something crucial that it will be useful for you and also for other companies and for your college as a way to, based on your explanation, can I implement your approach? Okay, so this is now the goal of this course, and for me, taking notes and recording my learning process about how to do that. And the reason of this series of videos is to put up practice and now have this social proof of work. Because where I'm living right now, I don't have any people that I can talk to, work with, especially in English. So that's quite challenging, but not impossible. And the way of how I'm improving my communication skills and so not only my analytical, but also my technical communications, is by taking notes from this course, okay, especially with Will's sentence, or for any other instructor out there, and see where are the finicky and see how they express themselves, especially when they describe is all of these topics. Not only here as a way to how OOP plays out in JavaScript, but also to see in other areas. So for example, in React, in Node, the hard part of JavaScript like this, the object-oriented programming and the asynchronization, okay, and then how you can now combine all of these concepts as a way to provide value to the customers, to your clients, and also, improve your technical skills. Understand is the business logic. Which industry do you want to show or provide your services? That's something interesting, and it's a beautiful journey along the way. But in any case, here we are. Okay, so here I'm gonna make a quick recap about OOP, how OOP plays out in JavaScript, a little intro to OOP. So how can we now create objects in the classical style of OOP, then subclasses, how the prototype change work, and now dive deep into the features that are relevant for not only this course but also for the JavaScript at this current state, with words like new and extend, and understand what it's doing behind the scenes, and now communicate with great precision. So the course here is like this. So this is the introduction of talking about is what is object-oriented programming paradigm. I'm not gonna dive deep too much into that because the entire reason of today's video is to take a look at now here subclassing with class, extends, and super. And we're gonna practice is how can we now subclassing with new and call. The finicky aspect of it that is actually feels like a hack rather than a design solution. And subclassing with factory functions. So here, this is all about in object programming is that how can we bundle its data and it is relevant functionality. And that's something that software engineers in the 60s, men and women, tried to figuring out. They come up with this idea. So the way of now you can create objects in JavaScript is by object templates, object dot notation, object create, and using a function to create objects. So the problem with the approach of creating functions from objects here, which is part of the solution one, is that not only you're able to add in all of these properties or data which is relevant and unique, but also you are now adding is all of this functionality, and you're duplicating this functionality every time you create a new object for every new data. So the idea here is that wouldn't it be better to actually do not repeat the functionality, put it in a place where we can now reference to that. So anytime we create an object with the relevant functionality, we just only point to that functionality. So in this way, we are being more memory efficient because now we're only creating is the data needed for this objects. And the relevant functionality, we're making a reference, we're pointing to that reference. So a good example here is that wouldn't it be better to, instead of creating multiple copies of your keys every time that you, for example, don't find it, wouldn't it be better to, instead of having multiple keys in your house, just to have one and put it in one single place where every time you go, you know that that's there. That's a very good analogy here for that. And the other is not only for your key, but also for your cell phone. Or, for example, if you store fish or chicken, frozen fish or chicken, wouldn't it be better to actually store them in the right place that any time that we need to access to, we can find them and it is ready, almost ready, so we can cook them. Okay, so this is exactly what now this particular approach of pointers is all about, is that we would like to, anytime we want to access to a particular object, that object contains relevant information, relevant functionality that we can now bind to this new object. That's the entire reason of this. That's interesting because that leads us to the next topic, and that is, well, how can we make this much more efficient? You know, how can we now improve this? And that's why we have, for example, object create as a way to design to say, hey, you know what? Yes, there is a better way. There is an alternative to this. Okay, that is using now the object.create. So object.create, what it's doing behind the scene is to indicate JavaScript, hey, the proto reference, okay, the proto, I want you to point now to this object, which is in our case our functionality. That's great, that's powerful, that's lovely. So on that topic, okay, follow that along. The idea here is to say, Well, once we create our object in this particular way, okay, so we put away our functionality into an object, aka we abstract that, okay. This is something that is called the sophisticated way of creating objects, something that you're not going to find in code bases, in professional code bases. But the idea here is that it is important to understand how do we get here and why, for example, the new keyword kicks in, because here you are now manually creating is all of this reference behind the scenes, which is great if you want to have full control of that. But would it be better, since we know that this is actually what we're going to do, would it be better to say, hey, let's a particular keyword to automate the referencing process for us, so we just only can get is the new data, and we now have a particular way of how can we abstract is data and its functionality. How can we put in one place data and its common functionality? So far so good. Okay, so on that topic, then I look at something interesting here, or we look at something interesting with the new keyword. Okay, so now that we know how we can manually and handcrafting creating all of these topics, specifically with the object.create, now it is time to see how can we now, using the new keyword, automate this particular process. And not only that, it also is, well, what is the benefits? What is the value proposition that this new keyword is doing for us? So, well, first is you need to define is a particular way to actually make use of the new keyword, and that is first the function constructor, like in the solution 3, like the function constructor. Let me see if I actually put it here. No, really? Okay, exactly. Well, in any case, but like, that's interesting. Like this, but I didn't have any code here. Okay. Anyway, no problem. But it's here. It's like this. So now here we got is the function constructor, where we're gonna make the use of this keyword for that, and now the functionality under the prototype function object combo. So remember, after all, everything in JavaScript is an object. Objects is a built-in object that has its own property method and internal methods, okay? And also the function combo that has internal methods like call, apply, and bind to string, as well as the instance methods, okay? And how these functions, okay, can have access to the object as well. So that's one of the reasons why they call here is that functions are first-class citizens, because you can run the execution of that, as well as you can put properties into that in the object portion under the prototype. So that's great, because with these solutions now we can look at how can we put data and its functionality, okay, by using the new keyword. What it's doing is to first, when you look at the function constructor, it will initialize the value of this as an empty object, and then it will look at this, which is this new object proto reference, and update that to point to the function constructor properties, or in this case to the function object prototype, as a way to now create this link for us, and then it will return the object after it evaluate this sentence. That's something interesting, and that's useful, because with this particular approach, now you're gonna find that in a lot of code bases out there. Okay, a lot of code bases out there. This is actually in professional, something that you're gonna find a lot in professional code bases. This is the way how you can create objects. And as you can see here, if you want, for example, to define nested functionality, and then you want to access to the proper data using this inside of the functionality, this is when JavaScript, or this is when the value of this becomes quite finicky. After all, it say, hey, because now the value of this behave different in different scenario or context, okay, in the function, the value of this will refer to whatever is on the left side. That's great. But in this particular case, if we define nested functionality, okay, like, for example, like this, if we define, solution 3, but if we define, for example, nested functionality, like this, exactly, let me put this here. Okay, so what if we want to define nested functionality? Like so. Okay, so what if we want to define is nested functionality? What if we want to define nested functionality that can be shared across different objects? So the value of this inside of a function is whatever is on the left side. But because the thing that is on the left side is undefined, you don't have now exactly you don't have now is that reference, because JavaScript say, hey, well, this is the empty, so this is undefined, and when the value of this is undefined, it will now make that to a window object. So that's not what we want, and that's the reason why we look at the scope and the value of this, how this is working behind the scenes, as a way to now keep track of those diagrams. And once we're able to understand what is the possible solution that we can come up here by using the arrow function, which is creating a closure, which means that now the value of this will be whatever is on the outer lexical scope, whatever is on the outer variable environment, okay? And now we can fix this problem. So far so good, because with this we are now able to see how can we're now able to see how can we solve this problem, extend and add more functionality to our applications, okay? And once we know how to do this, okay, you can now imagine what is the new keyword is doing behind the scenes. Is by transforming this, the data and its functionality, relevant data and irrelevant functionality, into a one single bundle. So this is just to this looks like syntactically, this is a syntactical sugar, because behind the scenes it's doing this, and this is exactly where we go now to move on. But before that, we need to understand is a couple of things. First, how the default prototype works behind the scenes, and then how can we make subclasses. So with the default prototype, the way how it works is that anytime you create an object, okay, JavaScript will look up the proto, and that proto will point to the prototype or to the object's built-in prototype. So that's great. But for example, another common built-in objects like functions and arrays. So these functions now has, if you take a look at the specs, this objects functions has now is inner properties, inner methods, for example, like call, bind, apply, and to string, that the language provides to this particular object, and also it can have access through the proto reference to the object's properties as well. Similar to the array. So the array here, you take a look at this. So when you construct an array, for example, hey, array, because I don't have here, this is a way how you can create an array using the array literal. And if you now inspect what array has, okay, so not only have it is length property, which is a magical property that anytime it change, it will call a particular property through the prototype change as a way to check what are the properties as a way to now update this property that has this array. So now here the array itself has a built-in internal methods like this, okay, as well as property instance. So this internal methods, okay, it has now a prototype or a proto that is pointing to the object built-in JavaScript, that in fact this is because we're calling it with the array template or template. But the other is, if you define is another array.to, you say new array, using is the function constructor, okay, it's going to automate several things. It's going to create the value of this, and it's going to set now to this array, okay. It's going to update now the prototype change behind the scenes and points that to the prototype that contains the arrays functionalities, okay, or that where it points that object, and then it's going to return is the new array. So when we take a look at the new array 2 here, it's actually contain the same thing, okay, and the prototype, okay, of these objects, now this is where it holds is the that now it is pointing to that. So as you can see here, this is the way how now properties can have access to this. This is how now objects can have access to other objects This is how subclassing actually is working behind the scenes in default. Okay, so now this object has a reference called proto that will reference is to, in this case, to the array object that inside of that will now have is a proto reference that points to the object that ultimately it points to null. But as you can see here, okay, this built-in objects, this is the way of how the prototype chains work by default. Okay, and you may wonder, why do we need to take a look at this? Because as a way to understand now how not only arrays but also functions, which is this built-in objects, place here and how they inherit the property and methods, now we can take a look at the next topic, which is subclassing with factory functions. Or in other words, how you can subclass or how you can write subclassing is with the object.create solution or the solution to, okay, and how lengthy and verbose it is. And then on the subclass, you're going to define is the set.prototype of, for example, like this, as you can see here, as it is, okay. And then on the subclass is when you're going to define is, hey, I want you now to set the prototype from this new object, this newly object that I created, to the current functionality, okay, on the pay user, and then now set the prototype of this of that function, okay, that object function here. Let me put it this way here. That's a way to, come on, man, why not? Hello. Really? But I do have, bro. I do have internet. Yeah, I do have, bro. I do, bro. Oh my god. Come on. Oh, for real? Okay, there you go. Can you? Oh my god, what? Not here, bro. Not here. Anyway, well, this is it, right? But this is how you can create now this subclassing here. As a way to now update is the proto reference or of our newly object created that points to that relevant functionality, and that relevant functionality now is going to point to the base functionality that we want to access to. This is a very manual handcrafting process. Perhaps a lot of people actually love to do this approach as a way to enhance or as a way to access to the property and methods, okay? But now with the new keyword, things started to be quite a little bit different because it actually automating process behind the scene. And that is, well, that with the new keyword here, I even put it here as the code. So with the new keyword, here. So by defining the function constructors, and under the prototype is all of the property and method that we want to have access to, okay? By creating now the subclassing here, like this, we need to indicate, hey, this is the new function constructor from this base class. That's one. Second, now this is the property that we want to, this is now the functionality that we want to point. But here's the catch. Here's the funny part. We are never is using the new keyword inside of our base class. Not at all. In fact, what we're doing is to use the call method from this function constructor and then pass the value of this, because remember, at the end of the day, now the new keyword, what it's going to do is to return the value of this with this new object. So we're just only going to call this that function constructor here from the base class, pass this value from this new function constructor, from the subclass based function constructor with the proper argument. And what is doing behind the scene is that we're going to receive is now the value of this, which is the object creation actually is happening is not on the subclass, is happening in the base class. Because once you are able to assign this, okay, now we are updating is the value of this as a side effect in this new object creator, okay? And that's what we're gonna use to add our property for this new function. So we can then, now, when it comes to actually update is the property, is the proper functionality, we're gonna say, hey, this new function constructor here, let me now assign, or let me now reference to the base functionality, and then define my own functionality here. So with this particular approach, which is what is doing behind the scenes, is this hacky thing. It feels like a hack, by the way, completely. It feels like a hack. It's saying, all right, this is now how things started to play out here. This is truly how now the creation of the objects is, especially from subclasses in the prototype object-oriented programming, is never happening at the class, at the subclass. In fact, it's happening at the base class that is passing out this new object as a side effect. We're adding is the property to that, and then we update is the prototype from this new base class that points to the base functionality or the base prototype, and then is when we add our new functionality for this base class. That feels very hacky. But again, this works. So this works because now when we get this, okay, when we get this, what is doing now behind the scene is what is doing behind the scenes, the class is now reusing this particular approach, especially when you're using subclasses, is saying, hey, we're gonna reuse this. We're not gonna reinvent the wheel from scratch, not at all. We're gonna reuse this, but we're gonna make to look like object-oriented programming. You know, we're gonna make you to feel that you are in object-oriented programming, but behind the scenes, you are using as a prototyping heritage change. Holy moly. And that's exactly what we are going to do today. as a way to wrap this up once and for all. Will you? No? Oh, really? What about another? It's nothing, right? You're not. But you actually, in fact, loading it. But what's wrong with you? It's like, oh, dude. Okay, quit it. Okay, now you detect that. Now we're talking. I think. But it says, okay, that's good. So we don't need to actually share this. Okay, be my guest. It seems that you have this, but I don't know why you are not able to access to that. Can you, please? Oh my God, what's wrong with you? Okay, no, you don't have any connection. Okay, let's go to switch to this. Come on, let's get it to it. Oh man. Okay. Okay. No, not gonna help me here. Wow, but this is not. Firefox always been finicky about this, bro. It's one of the things that I don't really like about Firefox. It's like sometimes you are. Anyway, Firefox being Firefox. Can you? Oh, you're not gonna die? Okay. Let's get it again. Shall we? Exactly. It's like, so Firefox application have a particular issue anytime it wants to get access. Yeah, anytime you want to get access, let's do it. Okay. So anytime you want to get access, or for example, internet is lost and then you reconnect on Mac, there is something wrong. I don't know what happened, but it blocked network operations that never complete those operations. Anyway, human made things. Who am I to judge? Okay. Whoop. All right. There you go. So here we are.
So here we are with our final approach.
So here we are. Now this is subclassing with classes, extend, and super. So subclassing with classes, with class extend and super, with class extend and super. Pa-pa-pa. Finally, create an object with a class. Create that Machiavellic laugh is because now we know what we have to do, because we're reusing all of this concept here. So create an object with a class. Okay, so create an object with a class. That's it. Okay. So here we are. Okay. So here we are. Here we are in our final section.
This is our mega standard approach now to which
This is our mega.
achieving So here we are with our final approach. This is our mega standard approach now.
This is the mega standard. This is our mega standard approach to build objects in EX6.
To achieving object-oriented programming pretend style.
Okay, this is our mega standard approach to build, or to achieve, exactly, to achieve object oriented. Okay, this is our mega standard approach to achieve object oriented.
Approach. This is our mega standard approach now to achieving object-oriented programming.
This is our mega standard now. This is our mega standard approach now to achieve object-oriented programming.
Pretend style.
Exactly, because pretend style
in a language, JavaScript, that is inherently a prototypal.
Exactly. That's right. That's right. That's right. So here's our final section, and this is now the mega standard approach of how to achieve object-oriented programming pretend style in JavaScript. Yeah, in JavaScript. Yeah, in JavaScript that is inherently, that is inherently prototypal in EXs. Which is exactly that.
Language, not an object-oriented one under the hood, but we are now able.
Exactly. This is not an object-oriented language under the hood, but we can now have the feeling of writing our programs to look like that, to look like OOP.
To really seemingly emulate a object-oriented language within a prototypal environment. And this is it. Wow, look at it. Beautiful. Left-hand side we've seen before. Note, I'm going to walk through it bit by bit. Object-oriented programming pretend style in a language, JavaScript, that is inherently a prototypal language, not an object-oriented one under the hood. But we are now able to really seemingly emulate a object-oriented language within a prototypal environment. And this is it. Wow, look at it. Beautiful. Left-hand side we've seen before. Note, I'm going to walk through it bit by bit now. This is our class version. We've got the function bit of the function object combo, that when we run the function will create an object in user 1. Now it's got a subtitle, constructor. But it's still going to end up here. Our say, name, and increment now look as though they're just there. Oh, no, 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 no. Behind the scenes, how many no's is it? Behind the scenes, they are being stuck in the prototype object. No problem. So we're going to do that left-hand side first, and then the right-hand side here. We're going to lay out exactly how extends and super are working under the hood. We'll figure it out together, but it's the last thing we do. Okay. Here we go. Line 1. I can almost leave this up here because it's really the same, but I want us to actually build it out. So line 1, what are we doing? Let's have Chris. What does it say we're doing there, Chris? In line 1.
Declaring.
Yeah, it's already slow.
We are declaring a class called user creator.
User creator, a class, which we know, I'm going to put it in pink, pretend it's something special, but we know the truth. It's just a function object combo, as they always are. And the function bit, yes, now has a subtitle, constructor. But and the class is called what, Chris?
User creator.
User creator. It has a function, which when we put user creator parens, it's going to run that function bit. But that function now, when we wrap it, we give it a subtitle. What's the subtitle we give it, Elliot? Constructor. But the function and the function object combo. But let's just call it constructor. There it is. So we run user creator with parens, we run the constructor bit of it. That is, we run the function in the function object combo. Let's make sure we put the
So we are going to see how to create. So we're going to see how to create. Okay. We're going to see how to create an object. Okay, an object like this. So we're going to see how to create an object with class. So let's start with our diagram.
object bit in as well. There's the object bit, it's a buzz object, and there it is. There it is. That's what we thought. And JavaScript immediately grabs the function, the constructor bit, sticks it on the function bit, on the function object combo, and then it grabs, David, what just below?
Say name.
Say name, and it puts it on what?
On the
prototype property of the object in the function object combo. And there it is,
Exactly.
Say name is stored as a method. So nothing has changed. To the very point that I could later add more functions directly, user-created.prototype, and put more functions in there. No problem. Okay, increment is also added. Increment is also added to our function object combo in its object portion under the prototype property. There it is. Okay, our setup is done. Elliot, let's get making our user one object. Take it away, man.
New constant.
Under the prototype property. There it is. Okay, our setup is done. Elliot, let's get making our user one object. Take it away, man.
Take it away, woman. So like this. So let's start with our diagram and setting up. Okay, let's start with our diagram and setting up the class user creator. The class user creator. Okay, so far so good, no problem.
New constant is created user one.
Yeah, initially
Exactly,
initialize,
we are creating.
and we're going to call what function?
The constructor.
Exactly. So what we're doing here is to, well, define the function constructors in this class object in the under the define is this function constructor, okay, and putting under the prototype property from the function object the say name and increment methods. All right.
Portion, yeah, the constructor portion of the class. But let's be clear, it's just the function. Yeah, in the function object combo, and we're passing what arguments?
Fill and
For we're going to create
A new brain execution
a
context.
new
execution.
Michael, you make me proud. Yes, of course, absolutely. With the mutator, that is the new keyword that changes up how this execution context plays out. There it is. There it is. There's our execution context. New keyword starts doing stuff. Nick, you did this well last time. Do you mind doing it again? Help me out first with the parameter argument combos.
The parameter name gets the value fill, and the score gets the value
Now, note people, just be clear. Running user creator runs the constructor portion. In other words, just as before, running user creator runs the function. That's all the class is. The function is now subtype of constructor. Okay, now new keyword starts doing its magic. Nick, help me out.
this object gets created
Mm-hmm.
with
Hold on.
This object is created here
Object, yeah, with
a proto
with a proto
set to
that links to the prototype
user creator.
that links to the prototype portion of the user creator. So that is linking to the prototype portions of the function creator.
the prototype object on the user creator object in its function object combination.
Mm-hmm.
There it is. Off it goes. Not particularly nicely done, but there we go. Yep.
And then finally, this object gets set a property of name,
So now we take over. We're doing our
Exactly.
of fill, and score.
Fantastic. But hold on. The object's stuck inside user creator. We don't want it in there.
It gets returned to user one.
It gets returned. The object with the label this, the designation this, gets returned out to user one. And there both
Exactly.
it is. With name, fill, score, for, and dunder, proto, dunder as a nice
Dunder,
little
proto,
cheeky
dunder.
link up to a set of functions. Thank goodness, otherwise we wouldn't have access to those functions. But nor do we want to have those functions on the object itself. Almost there. All right. So you.
How the f do you say dunder? Okay. Ok, subrayado doble o doble guión bajo. Alright.
User 2, the same, it would also have a bond to that object. We won't play it out. Let's do our check. By the way, look how fast we are now. Look how fast we get through the stuff that was so demanding earlier. Remarkable. Good job, everybody. So, user 1 dot say name. Michael, do you mind doing my lookup journey here for JavaScript?
Of fill and score of 4.
Fantastic. But hold on. The object's stuck inside his creator. We don't want it in there.
It gets returned to user 1.
It gets returned. The object with the label this, the designation this, gets returned out to user 1. And there, folks, it is. With name, fill, score, 4, and dunder proto dunder as a nice little cheeky link up to our set of functions. Thank goodness, otherwise we wouldn't have access to those functions. But nor do we want to have those functions on the object itself. Alright, so user 2, the same, it would also have a bond to that object. We won't play it out. Let's do our check. By the way, look how fast we are now. Look how fast we get through the stuff that was so demanding earlier. Remarkable. Good job, everybody. So, user 1 dot say name. The same, it fast we are now. Through the stuff that was so demanding. Good job, everybody. So, user 1 dot say name. Michael, do you mind doing my lookup journey here? We are now able to generate an object that does not have functions on it, and user 2 would be very similar, again with the specific data for user 2, but no functions copied on it, but they're still available. This would be it. It'd be pretty nice. But we want to produce a paid user that is just like a user, but a little bit more specific. Let's see if we can do it. Right-hand side here we go. There's functions that are going to work on those bonus properties. Perfect. Let's see if we can do it. Right-hand side here.
So let's start with a diagram and setting up the class user creator. First, evaluate the left expression. Okay. The left side. And now let's going to evaluate the creation of the object creation, the user creator, or the creation of the object. Exactly. And now let's go to evaluate the creation of the object. Oh, awesome. And now let's go to evaluate the creation of the object here. And now let's go to evaluate the creation of the object using new and class keyword. Alright, using new and class keyword. So let's evaluate the creation of the object using new. or using the new, no, using new and class keyword here.
Here we go. Here we go. I'm just putting this here to show we move on to the right hand side. Who shall I call? David! Excellent.
And now describe exactly. And describe the same name method, the same name lookup process. Okay, so now that we know what is doing behind the scenes, okay, so now that we know what is doing behind the scenes, okay, that's right. So now that we know what is doing behind the scenes, let's now create is a subclass from it, and that is the subclassing here from the solution for. And then we look now at this. Just solution for. Exactly. Solution for. All right. Now here we're gonna define is, well, how can we create a subclass from that? Creating a subclass with extend. Creating a subclass with extend. This is what it's doing now. React frameworks like React behind the scenes, or any other framework that make heavy use of class behind the scenes. So for example, Next, yes, Next, and that kind of thing. It's like, that's interesting. That's what they're making heavy use of that.
Help me out, David. We declare.
So let's go into define below our let's go to define below our, so in our diagram, so in our diagram, let's go to define so in our diagram, let's go to define is okay. Yeah, so in our diagram, let's go to define is right below the process of creating a subclass. Which is in our case is this. Okay. Things in blue are the blue fonts are things that new keyword are doing behind the scenes. Okay, just to recap, create a empty object and assign that to this keyword. Set the prototype dunder proto dunder value to point to the function prototype, or to the function constructor prototype property, okay, which in our case is user creator for our case exactly. And then is when you're gonna do that. Okay. And then is when it's going to return this value. So then return this with the property added to it. It's important to recap what's going on behind the scenes, so what you understand anytime you use now the new class keyword. It is doing the same as using is the prototype things, or using is the function constructor. Interesting, very, very interesting. Okay, so oh my god, no. Creating now a subclass with extend. So let's go to define right below the process of creating a subclass. Now take a look. So by looking at the pay user, or by looking at the right side of the slide, okay, that's right, and that is quite interesting.
A class which is really a function object combo. Give me a second while I put it on here. Name pay user creator. Hold on. A class which is really a function object combo.
So a class, when you say that, what is a class? It's a special type of object. It's a special type of objects here in classes. Something interesting. Well, yeah, let me take a look at now here. English here. That's right. Because classes are a template for creating objects. They encapsulate data with code to work on that data or the functionality. Classes in JavaScript are built on prototype, but also have some syntax and semantics that are unique to classes. For more examples and explanations, see using classes. So defining a class. Classes are in fact a special function, and just you can define function exactly. It's a special function. And just as you can define function expression and function declarations, there are two different things. Function expression is when you define a function that you assign to a variable. Function expressions like this, all right? Whether it is a function or a narrow syntax, okay? But also you have is the functions declarations, which is now defining there. And then you can round of that. A class can be defined in two ways. A class expressions, the same, and a class declaration as well. So meaning that you can now assign is a class, which is something that we're doing here, to a variable class expression, and the other is class declaration by defining your class field similar as a function, and then you run that. So here, okay, like function expression, class expressions may be anonymous or have a name that's different from the variable that is assigned to. However, unlike functions declarations, class declarations have the same temporal dead zone. Interesting. Restrictions as lets or cons and behave as they are. Okay. However, unlike function declaration, class definition have the same temporal dead zone. Restriction as let and cons and behave as if they are not hosted. Okay. Interesting. We call this temporal dead zone. Except the scoping rules is var is scoped at function block, whereas let is where let is scoped at block level. Yeah, TDC combined with lexical scoping. But again, this is now looking at the class. So they are not hosted. So class are not hosted, unlike functions. Okay. The body of a class is part of the curly brackets and is defined like this. The body of a class is executing in a strict mode, even without the use of strict directly. A class element be characterized by three aspects: kind, locations, and visibility. This is the body of this. Kind, getter, setters, method, or field. Location, static or instance. and then visibility, public or private. Together, they add up to 60 possible combinations. To divide the reference more logically and avoid overlapping content, the different elements are introduced in detail in different pages. Okay, method definition, getters, setters, public class field, statics, and private properties. Private properties have the restriction that all property name declared in the same class must be unique, and other public property does not have this restriction. You can have multiple public properties with the same name, and the last one overrides the other. This is the same behavior with object initializers. And this is now where we're going to take a look at the constructor. The constructor method is a special method for creating and initializing an object created with a class, which is the constructor, the function constructor, or the constructor method. It's a special method of a class for creating and initializing an object instance for. Static initialization, methods, static method, and fields. Static method and fields. Okay, fields declaration. Private properties. Exactly. And inheritance or extends. They call it inheritance, but after all, behind the scene, especially in prototype object like JavaScript, is have access to. They have access to the property and method. The extend keyword is used in class declaration or class expression to create class as a child of another constructor, either a class or a function. And the extend, which is now is pointing to the prototype, call the superclass constructor and pass the name parameter. But now things started to make a lot of sense of what's going on there. So you are now overriding methods as well. Super.speak. Are you gonna run this? And then this one. Evaluation order. When a class declaration or a class expression is evaluated, in various components are evaluated in the following order. The extend clause, if present, is first evaluated. It must evaluated to a valid constructor functions or null, or a type error is thrown. The constructor method is extracted subtitled with the default implementation. If constructor is not present, however, constructor method is extracted. Substitute with a default implementation if constructor is not present. However, because the constructor definition is only a method's definition, this step is not observable. The class elements property keys are evaluated in the order of declarations. If the property key is computed, the computed expressions is evaluated with the this value set to the this value surrounding the class. Okay, the class element property. The class elements property keys are evaluated in the order of declaration. Okay, the class element property keys are evaluated in order of declaration. If the property key is computed, the computed expression is evaluated with the this value set to the this value, surrounding the class, not the class itself. None of the property values are evaluated yet. So what it's doing is to set the object here. The class property keys are evaluated in order of declarations. If the property key is computed, then the computed expression is evaluated with this value to set to this value. Method and accessor are installed in order of the declaration. Methods and accessors are installed in the order of the declaration. Instance method and accessor are installed on the prototype property. Exactly. Here is when we evaluate that, it say now let me method and accessors are installed in the order of declaration. Instance methods and accessors are installed on the prototype property of the current class. And a static method and accessor are installed on the class itself. Instance method and accessors. Interesting. And static methods and accessors. Okay, there is a difference between instance method and static methods. Private instance method and accessors are safe to be installed on the instance directly later. This step is not observable. The class is now initialized with the prototype specified by extend, and implementation specified by constructor. For all the steps above, if the evaluation expression tries to access the name of the class, a reference error is thrown because the class is not initialized yet. If an evaluation expression tries to access the name of the class, a reference error. The class element's value are evaluated in the order of declaration. For each instance field, public or private, its initializer expression is safe. The initializer is evaluated during instance creation. Okay. The class element's values are evaluated in order of declaration. For each instance field, public or private, its initializer expression is safe. The initializer is evaluating instance creator and at the start of the constructor for base class. It's because it's there what happened there, or immediately before the super call when return for derivative class. For each static field, public or private, it is initialized. It's evaluated with this to set the class itself to the property in the class on the class. Static initialization blocks are evaluated with this set to the class itself. And the class is now fully initialized and can be used as a constructor function. For how instances are created, see the constructor reference. Because it's the constructor function that is initialized an object's instance of that class, which is after all this function constructor. Pretty much like the old way of how we do this thing. Pretty much the old way that we're doing this. Because that's something interesting. The object instance creations happens in the prototype oriented programming happens is at the base class, and then you're going to now receive that and add on the base class all of this. That's something interesting. That's very, very interesting how this mechanism works. Completely. Holy moly. That's very, very interesting. Binding with this with instance and static methods. So by doing this in the context of class, okay, it works as the value of this, because this is another thing, the value of this in classes, callbacks, arrow function, constructor, in class context, the value of this is different in each context. But in any case, a class can be split in two contexts, statics and instance. Constructor methods, constructors, okay. A class can be split into two contexts. So you have now two contexts here. So the static and the instance. Okay, static and instance. Constructor methods and instance fields, initializer, public and private, belongs to the instance context. So this is what it has in the instance context. And the static methods and the static, using the static, define a static method or field of a class. A static initialization block, see a link for more information about this usage. Static property, static method. Okay. Static methods are often utility function. That makes a lot of sense. Such as functions to create or clone objects, where static properties are useful for catch, fixed configurations, or any other data that you don't need to be replicated across instance. And this is the okay. Now you have this particular use case from static. Okay, if I want to define some utility methods, okay, such as create or clone objects, I'm gonna do this. But if I want to define static properties, for example, for catch or fixed configurations, by default, you might need to do this. All right, Jesus. Okay. But they are accessed on the instance of the class. Exactly, they are accessed on the class itself. Okay, their relevance to the class itself. So they cannot be directly accessed to the instance. But they are useful, they are useful for catching, especially they are property catching or fixed configurations for utilities. Catches and fixed configurations and functions for that. Exactly. Static field with initializer. Okay. The name of the static property field or method cannot be prototype. The name of the class field, static or instance, cannot be constructor. Okay. They have some restrictions here. Okay. 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 Anyway, but again, now that I look at this, okay, and how class context, okay, how can class can be split into two contexts. You have a static, an instance, and everything that is okay static. So constructor, methods, and instance fields initializer, public or private, belongs to the instance context, whereas the static methods, static field initialization and static initialization block, which usually are useful for static functions, for utility functions like create or clone an object, or in the case of a static property, for catching or fixed configuration. This value, this value is different in each context. Interesting. 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 Okay. Class constructor are always called with new, so their behavior is the same as function constructor. That this value is the new instance being created. So far so good. So that this value is, it behaves like the function constructor. So that this value is the new instance being created. Class method behave like methods in object literal. That this value is the object that the method was accessed on. If the method is not transferred to another object, this is generally an instance of the class. Static methods are not property of this. They are property of the class itself. Therefore, they are generalized access on the class, and that this is the value of the class or subclass. Static initialization blocks are also evaluated with this, set the current class, and that kind of thing. Okay. So this refers to the object itself. I mean, this refers to the object itself. Static. And the instance refers to the instance as well, to the object itself. Both of them refers to the object itself. Okay. 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 Okay.
Give me a second while I put it on here. Name paid user creator. Hold on, paid user creator, which is a function plus an object. Oh, hold on, I have to accept it. Oh shit, okay. Now it gets interesting. I'm going to use a different color pen for everything that extends does. Okay. We haven't got many pens left. Shall I use our, yeah. Oh, I should use red. Yes, I quite like that sort of complementary to the pink for class. I use red for everything that extends is going to do. Okay, first let's just get the regular stuff. So it's a function object combo. So its function is subtitled constructor. Subtitled constructor. There it is. And it has a property on its object portion, prototype. We know this is our regular stuff, which is itself an object, into which we're going to stick what function, David?
Increase balance.
Increase balance. And that's done for.
They are a special type of functions, my friend. They are a special type of functions. Public and private get a certain method or field. Okay. So after all, classes are a special type of functions. Okay. So I just want to know is what are the properties that this class has. Okay. So for that, let's take a look now at the ECMA specification. ECMA specification as it is. All right. The ECMA specification classes here. The ECMA specification on the, yeah, this is the ECMA, blah blah blah. You got it, ECMA here. Main class. What? Class union, class element, for real? The class object, no? It doesn't exist. Okay. Class tail. The operations class definition. Where are you on the functions and classes? Exactly. So far we have looked at parameter list, function definitions, arrow function definitions, method definitions, right? Interesting, by the way, totally. So parameter list, functions and classes, parameter list. So you can also use the yield and await, which is something interesting. Unique formal parameters, function rest parameter, parameter list, you know, formal parameter, static semantic, early errors. Okay, early errors contain expressions as a way to evaluate these expressions, which is kind of good, kind of awesome. Totally. Exactly. You can have object binding to this property, binding property list, binding rest property, as it is. Binding property list, like so. Can be yield or await. Array bind pattern, array binding pattern, Elysium, or spread element, yield and await. That's interesting. Array binding patterns, binding element list, Elysium, binding rest element, single name binder, binding identifier, and the initializer. This is just describing is this, you know, ECMAScripting language functions and classes. A simple parameter list has an initializer, expected argument count, functions definition, okay, as a way of how you can use this. Again, this is on the specifications, might not be working on some environments, you know, might not be working some environments, because most of the time some of these implementations, well, are quite ahead. A great place to look if that implementation actually exists is by looking at the MDN docs. But because here we are looking at the functions and classes language, and that's quite interesting because this is the statement, okay, statements and declarations. Even debugger is one of them, but statements and declarations, okay. And then you have now functions and classes, functions definitions. You can use prepend that with yield, await, and default. Function declaration, function with yield and await, or like so. This is function declaration and function expression. Functions body and function statement, static semantic early errors, evaluate function body. This is now is explaining you what's going on behind the scenes. Instance ordinary function objects, evaluations, arrow functions definitions, like that. Supplemental syntax. Consists body contains use strict. Evaluate consists body. Instantiate arrow function expression. Exactly. Methods and definition instead of a function. Similar to generator functions and definitions here. Evaluate generator body, instantiate async generator functions definition, something that we're not going to see that, but we want to take a look at now at this class definitions here. Class binder identifier, it can be an yield and await as well as something called class tail. This is class declaration, class expression, class tail. Okay, the class tail. Interesting that they called that class tail. The anatomy of this extends left hand side. It's interesting because this is the anatomy of this, and the portion of what we call is extend. The anatomy here is called is the class tail. So here you can put is the extend, the class tail. Class heritage is extend here, left hand side expression. But JavaScript only support is extend. It doesn't support is interface. Okay, interface in JavaScript. That is a TypeScript thing. You know what I mean? In the end, that is a TypeScript thing. That's quite interesting by looking at this. The class declaration, when you have the class keyword, everything that is in bold, it means that it's a reserved keyword. Okay, and then you have the class inheritance. Class body has class element list, where it can be a class element as an array. It can be a class element or a class element list. And a class element has the method definition. Exactly, can be the method definition, the static method definition, field definition, or the static field definition. And the using is a static here, especially in the method definitions, and some utility functions, such as create a new object, clone a new object, or in the static field definition is for catching or have pre-exist configuration. That's interesting. Class static block. Okay. All right. Static semantic early errors. Early errors. Class element kind, constructor method, static semantic, is a static and the evaluation. Oh, exactly. So what's going on when you evaluate this? But this is now is functions and classes. But what if I want to take a look at the class as an object? You know what I mean? Class definition. Because at the end of the day, classes are a special type of functions. Well, if you want to take a look now, okay, if this is a special type of function, it means that it will return some property. So, for example, if I say count user1 of the new, okay, let me define that class first. Say class, which is a special type of object, a function, user here, where we're going to define this with a capital letter, the first capital letter, by saying, hey, the anatomy of this contains a constructor, where here you're going to receive is the parameter that you want to, in my case, names and coins, right? Or score, like that, score like that, and then you say, okay, now let me use this keyword, which will point to the instance by first creating an empty object and then assign is these new values, and then assigning all of this property to this new object. Come on, score equals score. Okay, and then define some method here. So for example, is like login, right? When you now can define this as this shape and do this. Hey, console. We can say is login. You are logging, right? That's all. And another method here, which is increment, and now on the functions methods, or on the methods here, as I mentioned here, because the value of this will be defer, at the end of the day, fields declaration and methods like this. Okay, this is a methods declaration as it is. Well, you tell yourself, it's like, hey, this is now the value of this, which in this context represents this instance, the value of this instance. That's something important to remember. Okay, and how you can make sure about that. Okay, how you can truly sure that. So when someone actually asks you, hey, where do you get that? Is here. Constructor method definitions. Okay. So on the method definitions, okay, property parameters like this, or a generator as well, or an async function, or an async generator. With computer keys, you say expression and the parameter here, or an async expression. Given the following code, you're not able to shorten this to this. Okay, you're not able to shorten this to this. Method definitions are not constructible. Okay, using super in method definition. Method definitions in classes. Okay, method definitions in classes here. So this is exactly inside instant method, this and super were like normal methods. Usually this refers to the instance itself. In subclasses, super lets you access to the prototype of the object that the method is attached to, allowing you to call method from the subclass. So super is attached to the prototype. Okay, it's attached to the prototype, which is by default is the constructor. So the value of this, okay, inside instance method, this and super were like normal method. Usually this refers to the instance itself. So when you are now when you want to work with the relevant data, okay, the value of this represents is the data of that instance, which is great because now you can say, hey, the score, you can do something like this. And that's it, right? And that's it. Holy moly. And that's it. So here, when you want to create now this new user, okay, and you're going to pass now Bob with a score of 7, okay, and then write down you want to actually access to that, say increment, okay. I want you to now want to know what happened with score, and then login. And that's exactly what it's doing. Call to evolve. Wait, what? Anyway. But that's exactly what it's doing. Hey, you're logging. So this is of course cleaner, but there is a lot of mechanism and things going on into that. One of the great things of now being able to describe what's going on here as a way to remember that the end goal of this is to bundle data and its relevant functionality together, okay. So once you want to work with the relevant data, which is this, okay, now this inside of the methods, okay, so the value of this inside of the normal methods refers to the instance itself, refers to the proper data. You know, now things started to make a lot of sense. Now things started to make a lot of sense, which is something that I wasn't able to describe what's going on, but now I do. Now I do. Oh my God. Okay, that's very, very interesting. That's completely interesting here. Holy moly. Okay. This is how we can create is our object, okay, and what's going on behind the scenes. And so far, so good. Okay, so far so good. So now when it comes to actually create a subclass here, how can we do that? You know, let's get into it.
For us now, rather than manually assign it there, it's just done by putting it in the class, structure. It's a function. Okay, so what does extends do? Extends user creator is going to do two major things. We want any object that comes out of running page user creator, which will be page user 1, we want that page user 1 to have a bond to this set of functions. Well, that makes sense. You know that. That's going to happen by using new keyword, running page user creator. It'll get a bond automatically to the set of functions in the proto reference. No problem. But we want that object to also have access to this set of functions. So what, when it goes looking in here for, say, name, do we want to happen set? When that object goes looking for, say, name in here, doesn't find it, we want it to go looking.
Its proto link should link up.
It's forwarding to
Red means extends does it. So the first thing extends does is set that proto as a reference up to user creator prototype. No problem. We did it manually before. Prototype. We did it manually before, if you remember. Using user
by using the user prototyping and then assigning the prototyping.
Proto up to that user creator prototype. We did it manually before. Now extends does it for us. Extends automates that for us, and the bond is made up to there with the help of extends. But extends does something else. We want to, when we run page user creator with a new keyword, we want to run the constructor portion that we then want it to use the work we did earlier of assigning properties in user creator, to use that to help create the object with the right properties on it. Now remember we did that earlier? We used user creator with call and then we assigned of this. We ain't going to need to do that anymore. Now, inside of the function, the constructor bit, when we run page user creator, creates our object with the help of the new keyword, we're going to run super. And super is going to say, go run the user creator bit. So it'll be a little bit finicky how it does it. We're going to see in a second. The spec explains it. I've only ever seen my favorite duality explain it explicitly. Otherwise, no one else explains. Spec explains it. I've only ever seen my favorite duality, the user creator bit. So it'll be a little bit finicky how it does it. We're going to see in a second. The spec explains it. I've only ever seen my favorite duality explain it explicitly. Otherwise, no one else explains. So it'll be a little bit finicky how it does it. We're going to see in a second. The spec explains it. I've only ever seen my favorite duality explain it explicitly. Otherwise, no one else explains. In a second. The spec explains it. I've only ever seen my favorite duality explain it explicitly. Otherwise, no one else explains.
Okay.
The super is going to go and take us over to user creator and run its function to create our object. And by the way, the super is going to go and take us over to user creator and run its function to create our object. And by the way, unlike here, where we made the object inside page user creator and then we mutated it one layer out, we're actually going to make the object, wait for this, we're going to make the object inside of user creator. But it's going to have its proto auto set to page user creator's functions. We'll see in a second. But that means there's one other thing that extends does. I'm not sure if you can tell this. It does this. It does this. It does this. It sets paid user creator, the function, its proto to the user creator function object. To user creator. Let me just extend this down a bit here. Please, they're all up at once, am I? Okay, let's extend that down slightly. The second thing it does is we have another property on page user creator, proto, that normally would just link to function.prototype, where all the shared
Exactly.
that a function has access to will be. This is the moment we go, and just give up. But it links up to the user creator. We're going to see what this is going to let us do, people, is that when we run page user creator, the function, it's going to create an object inside. We're going to call super, and that super is going to go, what am I? What do I need to go run? It's going to go look at proto, see user creator, and go run it. Create our object. Promise 1% I want to dive into this piece.
I'm kind of extending this piece a bit. So if you left off constructor on page or creator, it's going to look in proto for constructor and just run constructor directly.
That's a different factor. If you leave off constructor, it's going to automatically put in a very simple constructor which returns an object. So look, oh my god, look at what they call this a subclass, right? So not a base class, but a subclass. Look at what it has on it. That was just from, and everything in red was added by extends. One portion ensures that the objects that come out of running this function have access to these functions. That's what the proto bit on the function collection of functions ensures. The other portion, the other consequence of extends, ensures that the super, which when we run pages of creator we're going to run, makes us go and run user creator to make the object there. And that is stored, or that link is stored in the proto, which when we run pages on the function collection of functions ensures. The other portion, the other consequence of extends, ensures that the super, which when we run pages of creator we're going to run, makes us go and run user creator to make the object there. And that is stored, or that link is stored in the proto. That is where it's stored. If you overwrite proto, then the super goes, I'm not there anymore. When you call super inside of that, it is absolutely heading to proto and going to look up here. So if you overwrite it with null, that super ain't going to do anything. Okay, let's see it play out. This is a lot of laying out. We're going to see it play out now. It should become a little bit clearer. Right, left-hand side here. Chris, what are we doing? We set up our whole paid user class with it as an extension of user creator. Now we're going to declare what?
Constant of paid user.
Yeah, perfect. Of paid
User1.
user1, which we don't initialize or anything yet, while we go off and call
Paid user creator.
paid user creator. Are you ready for this? I'm ready for this. This is our final code, folks. Paid user1 is actually getting dark. This is a very bad sign. Okay, this is our final code. We're like down to our final code. This is our final execution concept we're going to do tonight. Sorry, let's pretend today. All right, paid user1. Let's pretend for ourselves it is still today. Called with that mutative, that powerful new keyword, call paid user creator, pass in Alyssa 8 and 25. Okay, here it goes. Big execution context. There it is. Into it we go. And the first thing, room there. The first thing in local memory are our argument parameter complex. Let's have Michael help us out with those. We're calling pages creator. That means we run the pages creator function, which happens to now be called constructor as part of a class, but it is just a function here. And that says we're accepting paid name, paid score, account balance. So talk me through the parameter argument matching here.
Exactly. The parameter matching here is that we are
Beautiful.
assigning its pay name and pay score, as well as
25.
balance, account balance,
And that, what am I thinking about?
to make
And
the
now we're calling with
to
the new keyword.
Alyssa 8
Nick
and
is over
25
here. What does
respectively.
this get us doing? Oh!
respectively.
It's not especially area this time, because now in a class it does do something weird. So there is a this assignment, but it is uninitialized. Nothing there, okay? And we immediately must have a super call before we want to refer to that this. It is there, it's uninitialized, but we cannot refer to it. It's not undefined. We can't go console log above the super, which is hopefully going to go and call the user creator to create our underlying object. We are not going to run user creator and have it have a side effect on the this we create with a new keyword here. No, this fundamentally changes the class structure, how and where our pertinent object, the one we're creating, that will eventually be called in pages1, is actually being born. It is not being born in pages creator. It is actually going to be born in user creator. And that is a design decision of the JavaScript team to make it be born in pages creator. To make it be born in user creator construct function. It is born in there. And then it is automatically returned out and assigned to this out here. Versus, remember in the previous version, we had side effects on the object we created here. Okay, so let's start doing this. So we're going to call, so it's unassigned right now, uninitialized right now. We call super with what arguments, Chris?
Paid name,
Which
parameter,
is,
and paid score.
which have what values?
Alyssa and 8.
And they're going to go into as what parameter argument combos in the constructor?
Name and score.
Name is going to be Alyssa,
Name,
score is going to be inside the execution context. Okay. Create the execution context. I'm actually going to do this. This equals, I almost want to say pseudo equals. You can't assign to this, behind the scenes is what's happening. This is going to equal the return value of calling super. Now, I'm going to actually show you briefly what actually happens. It does this. There's a new thing in JavaScript that allows you to call a constructor function, that's a function that should have a new keyword in front of it, that allows you to do it without the new keyword. It's called like, to call a constructor function, that's a function that should have a new keyword in front of it, that allows you to do it without the new keyword. It's called like reflect.construct. Can someone type that into Google? I think it's Mark, do you mind typing reflect.construct? It's MDN. Reflect.construct. I'm actually going to show you what this exactly does behind the scenes. I'm going to do it in red because it really is about the extent that makes this happen. Okay? So it's going to be reflect. Does it say reflect.construct? This? Yeah. Reflect.construct. Okay? Its first argument is the function that's going to be creating the object. But what is the function going to be creating the object? It is
the user creator.
Because it goes to look for proto and it's user creator. This is what it's doing.
So this is the target. Static method is like the new operator, but as a function. It is equivalent to call the new target. But it's equivalent to call the new target. Reflect.construct static method is like the new operator, but as a function. Okay. It is equivalent to calling new target and the argument. In additionally, allow to specify a different new.target value. Let me now call this function and pass this argument. And what is the argument return? A new instance of target or new target if present, initialized by target as a constructor with the given argument list. Reflects that constructs invoke the construct of the internal method of the target. Interesting. Object internal methods of the target. Functions objects also have the following internal method: call and construct. Because after all, this is a function, and everything in JavaScript is an object, and functions are a special type of objects, and classes are a special type of functions. Oh my god, you see what is going on? What happened is that with this construct here, which corresponds to the trap here, with the handle construct, which allow you to call that construct function constructor. It allows you to call that function constructor. Okay. Reflect.construct, invoke the construct and all your internal method of target. Using reflect construct for that. Because now it's going to invoke is the construct internal methods of that function. The function construct in the function construct internal method.
argument is the function that's going to be creating the object. What is the function going to be creating the object? It is
User creator.
because it goes to look for proto and it's user creator. This is just what it's doing behind the scenes. User creator, and then the arguments. Alyssa, I promised myself not to do this bit, but okay. And then the function whose prototype object we want to have the returned object that comes out of the call to super point to, which is the function whose prototype object we want to have the returned object that comes out of the call to super point to, which is paid user creator. So paid user creator, paid user creator. But for our purposes, and then that returns out an object into the this. But for our purposes, just think of it as the super. We can write it a couple of ways. Think of it as the super being. Super goes, oh no, what do I want to run to produce the object? Well, the object I want to have is the user object.
The
we're gonna
user
add a bunch of
object.
stuff to it. So go run the user creator constructor. How do we know to go run that? Because extends put in the proto a reference to the user creator function, the user creator constructor function. So super goes, no, what's super? You can almost think of it like this, that in local memory, super is set to user creator. Not literally, but you can almost think of it as super is set to user creator. Okay. So super is set to user creator, called with Alyssa, and 8, and then that's going to be stored in this. These are just 3 different ways of saying the same thing. Don't worry too much about this reflect.construct thing. It's just a new way of allowing us to, and behind the scenes is really what's happening. We're running user creator with, the new keyword.
We're running is the constructor function, which is we are running now is the function from this class, this function object,
Word in front of it.
and then the extend keyword is not only updating is the proto reference internal from the prototype, but it's also updating the current proto to points to the user creator.
It's going to return out the object that we know well and love, but we're going to control the returned out object proto to not be to user creator prototype object, but instead to be to paid user creator prototype object. Okay, let's just do it. That's not what I regret bringing that reflect.construct thing, but just know that what we pass in last there means that this running of super user creator is going to set the prototype to be paid user creator prototype, not user creator object. Okay, let's just do it. That's not what I regret bringing that reflect.construct thing, but just know that what we pass in last there means that this running of super user creator is going to set the prototype to be paid user creator prototype, not user creator prototype. Here we go. So super refers to let's go run user creator, just like we did before. Go run user creator, make the object, but before we used that previous work and applied it to the local object in paid user creator. Now we're going to make the object inside of user creator, not inside of page, and we're going to return it out into paid user creator. Let's do it, and then we're done, people. So calling super inside of user creator. Here we go. So super refers to let's go run user creator, just like we did before.
So super refers to a base
Go run
class.
user creator, make the object, but before we used that previous work and applied it to the local object in paid user creator. Now we're going to make the object inside of user creator, not inside of page, and we're going to return it out into paid user creator. Let's do it, and then we're done, people. So calling super really calls user creators constructor function. Let's have Nick. Save me, Nick. We're calling super. It's really user creator with the new keyword in front of it. Its output is going to be stored in this in page user creator. Talk me through the execution context of user creator with the new keyword. Help me out, Nick.
So the new keyword.
Let's just do our arguments first.
Arguments,
So our
This is
arguments
the
are-
final
arguments are
argument
being
here.
stored.
Those are our parameters with the arguments.
Oh, with the arguments, Alyssa
Yeah.
and 8.
Perfect. Hold on. Alyssa is our argument assigned to our parameter name, and score, and then score is 8. It's being called with a new keyword because super is really calling user creator, the constructor of it, with the new keyword to make the object. But note we're making it inside of here this time, not out here. Okay, so let's do the new keyword stuff. Go ahead.
So new creates a this, empty this object,
Beautiful.
which gets
This
set
new
with a
empty
Proto
object
to where?
to point to the user creator, to point to the prototype property of the user creator function
Normally it
combo.
would be to user creator dot prototype this object here, wouldn't it?
Mm-hmm.
But by the nature of the class design, the super sets this object's proto not to the function user creator dot prototypes object. Instead, it overrides it. And David, where does it set it to?
Page user creator.
Page user creator.
Pay user creator.
Fantastic. And that's what I was regretting bringing up, but sort of showing you under the hood what's happening. It says run user creator with a new keyword, pass in these arguments, and set the returned object proto to.
And set the return proto to the pay user creator. And set the proto reference to this particular subclass in here.
That's all this. This is a new way of doing stuff in JavaScript in ES6 that allows you to manually control more of what the new keyword does. That's all it was, but we can see without bringing that up. But forgive me for bringing that up. It's worth, it's an interesting thing to see as a new way of doing this stuff.
Don't blame
Yeah,
me.
we now set our proto. Remind me again, Nick, to what?
Paid user creator.
Not prototype, that object. Yeah, exactly. Let's just draw the line through. It's a long way. Can I get my line? Ooh, almost. There it is. And that object is going to have what properties added to it, Nick?
Name and score.
Then name and score, set the value there.
Name and score. This is our final code. It's great, but it's stuck inside of the one.
So the reflector construct is a way of how you can have much more fine control about how to set up your proto reference using the new keyword.
One was this is the object. Two was proto was set, but
Exactly, the value of the new target operator, which usually specifies the prototype of the return object if your target is not present. Exactly. If new target is not present, it is value defaults to the target. Holy moly. And because extends points the proto reference inside of the prototype to the base class, now here when running super with reflector construct, you say, hey, let's go to create this new object with this argument, but let me now modify is their proto, there's reference to this current object that I created, which is something that when you remember how to do that before with new keyword without classes, you have to now specially indicate or manually indicate the proto reference for that. How to update the proto reference so it can have access to the base class and property. Holy
in a really
Mary.
interesting way. Alright, and 3 is to do what, Nick?
It's returned to the constructor of paid user creator.
Fantastic. So its execution context in what local in what
The this object.
in the this, exactly, it goes and sticks in the this. Fantastic. But folk, it was even a revelation to me, I say even, probably especially, a revelation to me, that is awful, I apologise. It was a revelation to me that the construction of the object itself is happening
On the class, on the base class.
in the user creator constructor and then getting returned out one level. Okay, where it is returned with name, Alyssa, score, 8, and then proto is a bond. Quite conveniently, I'll just join it on there. Oh, no. Oh, okay, let's just get rid of it from here. Let's just say here it was up to here. There it is. And now we can see where it actually links. Oh no, this is getting horrible. I regret this. Let me get my purple line. There we go. Nice and tidy now. There we go. And now what do we add to this object, Nick? Oh, that was in our prototype, easy slip to make. Account balance with what property value? Good. And to our last online member who's still with us, because they can leave the room anytime. That is the blessing of being the online audience. Anytime they can leave the room going, it was good. Next time.
Yeah, exactly.
Grab this object,
It was good.
we're calling
Next time.
page user creator with the new keyword. So, Nick, we've got our lovely object here in the this. What do we do to it automatically?
We return it to paid user
To
1.
paid user 1. Nick, I'm so impressed. Out it comes. There it is. Into paid user 1, where we find, let me just get my handwriting really neat for this final piece. My name. Seth, stop packing your stuff up. I can literally hear the zip of your bag, Seth. Okay. And the proto is conveniently set to exactly what we want. So here we go. Our final lookups. I'm actually out of breath from so much.
Okay. That's quite quite a that's quite wild, bro. So this is our final diagram. So anytime we run the new keyword with a class, especially with extend, it say now let me update the reference of this new object that I'm going to create uh, here to point to that base class, and then when I run the super, I'm just overriding is this new object that I create. Okay, so the extend, what is doing behind the scene is to modify is the proto from this, holy shit, the proto from this reference. Okay, so extend is saying, hey, I'm going to modify is the prototype of this class, of this subclass, to points to the base prototype function object. Okay, and then when I run super, what I'm gonna do behind the scenes is to say, hey, let me now is use behind the scenes is this thing called reflect, which is a namespace that allow me to uh, trigger intersectable intersectable in JavaScript inner methods or JavaScript object inner methods, for example like construct. Okay, which is what you're gonna do is reflect the construct is giving you the ability to say, hey, I want you to now run these functions, but let me also allow to define is the prototype for this. Okay, so I want to have much more control about the prototype in when using the new keyword, which is something that honestly you quite frankly don't have that. God damn. God damn it. Totally, man. Totally. Totally. Oh my god. It's like totally, bro. It's like totally, bro. It's like totally, bro. It's like totally, bro. Mm-hmm. So anyway, now things started to make a lot of sense. So anyway, that'll be all for this video. Take care. Bye bye.